Hello there. In this video, we cover the topic of functions, of course, in R. Now, our function is defined by its name and by a list of its parameters, often called arguments. And those are the inputs of the function. So usually a function has some inputs, something you feed the function, and then the function does something, usually returns an output. So using a function or calling the function, executing the function, I might use those terms interchangeably, is done by typing its name followed in brackets a list of the arguments with a specified value. So careful here, each argument has a name coded inside the function, but then when you call the function, you obviously give it a specific value that you, the user, wants to, well, give the function. And so each argument is followed by the sign, or can be followed by the sign, because some arguments don't need to be specified, the sign equality. Okay, so overall, this is the general syntax. You do not necessarily need to indicate the names of the arguments, only their values, as long as you follow the correct order. So yes, if you know that what goes first is whatever this argument is, you could just use function name, value 1, value 2, value 3. But obviously, the order matters, and we're going to see an example of this in a moment. So some arguments must be specified. If you don't specify them, if you don't enter a value for those arguments, you will get an error. However, other arguments are optional because a default value is given already. So if you don't enter anything for a specific argument that has a default, well, the default is used, and then the function will work even if you haven't specified that argument. Again, it will just use the default value. Now, can you name some functions already covered that we have seen? Hopefully, yes, because we've seen quite a lot of functions. Sum, mean, log, square root, all of those are functions, right? A keyword, then bracket, and then you feed something inside the bracket, and then the function returns something. Now, to make all those points explicit, we cover a specific example here. We use a log function. Now, you can use the help menu to get information about the log. It will tell you that the defined usage is log first argument called x. X doesn't have a default value, and then the second argument is called base. And you see this syntax base equals x means that the default value is exp1. Exp1 means e, the mathematical constant e to the power 1. And by the way, so in RStudio, I probably mentioned that before, but let's just repeat that if you type question mark and then the name of whatever function, you will get it there on the side. Okay, it was already there because I did this before, but let's say that I type another one, R norm. I get help on the R norm, but then again, I go back to question mark log, and then you see I get a description of the function, and then this is the usage. First argument is x, second argument is base, and again, base as a default value of exp1. So let's see a few usages of the log function. So log x equals 5, base equals exp1. What does this do? Well, it gives me the result of the log. And I think you know what a log is. This is the number that if I take the base to the power of that number, I will get 5, right? We can check this explicitly in RStudio. So this number so the base is exp, so I should take my base base 1 to the power of this, I will get 5. Obviously, exp is in fact e to the power of something as a function, so exp of this will also give me 5. So again, just so it's not confusing, exp1 is exponential of whatever number. So itself is a function, right? Maybe this is slightly confusing, right? So, but this really means e to the power 1, so just e. Now I take e to the power of this, of course I get 5. But it should work to have this function is already exp to the power of whatever is there. So exp, this number also gives me 5. Now, as long as our ordering is the same as specified in the description of the function, we can omit the names. So this is what we said before. If you just type log 5 exp1, it works. Obviously, it's gonna give you the same number as before. But of course, the order matters. So if you type the opposite, if you type log exp1 5, well, you get a different result because the meaning of this is very different. Now we're saying, okay, now the base is 5 and the argument, the x, is e to the power 1. So we're saying, okay, if I take 5, the base, and I put it to the power of this, I will get back to this number. All right, let's try. In case you don't believe me, which would be quite tragic, but I understand sometimes you can be skeptical. So 5 to the power of this should give me e, the constant e, right? Which indeed is this. Let's double check. Exp1 is the same. Now, again, base equals exp1 in the description of the function means that this is a default argument. So the default of base is e. And so we don't need it. If what I want is log 5 in base e, and by the way, this is a natural logarithm. So this is in mathematical notation, this would be ln, right? So log 5 in base e is ln 5. Well, I can just type log 5 because, of course, without base specified, it goes to default, which is already e. So I get this. Same result as before, here and here. Okay, that should cover most of the normal use cases. Now, 2 more examples to extend this a bit. If you go if you name the arguments, you can go in whatever order, right? If you name the arguments, you could use this, but with reverse order. Obviously, it's gonna work, right? So if I put this at base first, it's gonna give me the same thing. But also, R is smart enough that if I name just one, and here there's only 2 arguments, that's gonna work as well because, well, I know base is this, so the second argument, it's unnamed, but it has to be x then, because again, there's only 2 arguments in this function, which is the point made here. And the last point is that you can be a little lazy and you don't have to type the entire name of the argument. So if you type B only, it's gonna work because, well, there's only 2 arguments, so there's no confusion possible. Don't do that if you have 2 arguments that start with B, because in that case, well, that's confusing. But again, this will work. B is used instead of base. Okay, just a distinction here. You can use a function without typing any arguments, but there's 2 different scenarios where this could happen, and they're quite different. So, for example, if you use the function sec without arguments, it's going to give you 1. That's the result of sec without any arguments. If you use the function date without arguments, it gives you this, the date of, well, whenever you type this. Now, both these work, but there's a difference. Sequence as arguments that all of them have a default value. So all of the arguments have the default value, so you can use sequence without any specified arguments, and you get whatever is the result when all the default values are used. Date is a function without any arguments. So it's possible you can have a function that just does one specific thing. It doesn't need arguments. In this case, date is an already created function in R. It just gives you the date, so it doesn't need any arguments. I suppose that's a bit of an aside. And now we get to the big topic of developing your own functions. Yes, very exciting. You want to be able to create a function of your own that does whatever you want. And so here there's a bit of overall comments. So yes, it's an important part of coding in R, and honestly in coding in most languages, to create your own functions. Indeed, whenever you are performing the same task many times, only that you use different inputs each time. Well, it's much better. It's much better to create a custom function that does this specific task with a specific set of arguments that you can then change each time you call the function. So it's much better to do that than to manually copy paste your code many times. And then if you do that, you need to manually change all the inputs in your code. So this is very inefficient, but you'd be surprised how often I see students still doing that. Like they have a certain calculation they do, but they need to do it many, many times for different parameters. And instead of just defining a function one and calling their function, like say 10 times, they might copy paste their code 10 times and change the numbers inside the code, okay? Which is very inefficient, of course, because it's very prone to error. If you've made a mistake somewhere in your code, you've actually copy pasted 10 times, you need to fix it 10 times when you discover the error. Well, if you discover error in your function, that's possible, of course, but then you're gonna fix the error only once in the function. And of course, it's gonna make your code cleaner, shorter, easier to debug, and easier to update and improve when it's nicely in a function. Okay, now all of this might sound a bit abstract. Hopefully, those kinds of advice will make a bit more sense when you start actually coding. So the general syntax for a function is that you give your function a name. Sorry, well, we'll see an example. What you give your function a name, and then inside this function, you put the keyword function. So you need the keyword function, and then you have the list of all your arguments. Those arguments, you give them names that you want, with or without default values. And then curly brackets is whatever your function needs to do. So body of the function, and then you close the function. That's the general syntax. Obviously, it's going to be clear when we present examples. But list of arguments here, a list of your named arguments. Sometimes those are called formal arguments. I doubt this matters too much, but still, I give you all the information. And body of the function, well, whatever you want the function to do. All right, that's all abstract. So let's create a function here. Okay, this you already know. To call the function, you need to type the name and followed by the effective arguments between brackets. Okay, so let's see the example. I'm creating a function like this. So hello is the name of my function. I create this function called hello. Now I put, so this again is the assignment operator. So it's like saying I put inside hello an object that is a function. So I need to use the keyword function. Now name, I define this. So name is, well, is the name of my argument, right? So this function has only one argument that I call name. And this between the curly brackets, everything in between the curly brackets is what the function does. So here, this is a function that is gonna, cat is used to put characters together. So the function is simply gonna take this sentence, hello, my dear. See here, put name, but this name is whatever the user chooses it to be. And after that, also put the exclamation mark. So, okay, that doesn't sound too useful, but it's just a simple example of creating a function. And you see, when you execute the function with name specified to be whatever you want, in this case, Josephine, the result of hello name equals Josephine will be whatever the function does. But here the function just says, just returns, hello, my dear Josephine. Of course, if you call it with different names, you get different results. Hello, and here we practice laziness in the sense that we don't type the whole name of the argument. Hello, my Jinxia, well, hello, my dear Jinxia, and so on. And then here, because there's only one argument, hello Bernard will work because there's only one argument that can be filled with Bernard. Now, question for you. If you just type hello bracket, is it going to work? No. No, because there's no default argument. So try it. We can try it together. If I declare this function in my our session, and I type hello without arguments, it's not going to work. Name is mandatory. It doesn't have a default value. Of course, I can change that straight away and type hello. I don't know, Louis. And now this is my function. Now hello without any arguments would work because of course the default argument is Louis. A few comments. The body of a function can be a simple R instructions or a sequence of R instructions that can be very long, very complex in some cases. In the latter case, so if it's more than a single line, you need the curly brackets. Now, if it's not, if it's only a single line, you actually don't need a curly bracket. But I would say just for good practice, always use the curly brackets, right? I don't see why you wouldn't use curly brackets. So several R instructions can be written on the same line as long as they are separated by a semicolon. Okay, yes, but that's not my advice. So semicolon tells R, okay, this is a new line to execute. But I would say for readability of code, just start a new command, start it on a new line. Okay, exercise for you. Should be a simple one in light of what we just presented. So I want you to create a function called favorite. Well, the name of the function is favorite, not favorite bracket, but I think you see what I mean. So there should be a single argument called course. So that's the name of the argument, and the function returns my favorite university subject is whatever course is as specified by the user. But there should be a default argument. So there should be a default argument for course that is, of course, ACTL1101. And here there's a bit of a twist. Use this function that you don't know to put whatever the name of the course is in uppercase if it's not in uppercase. Okay, just a bit of a twist. So if somebody types just favorite, well, of course it should display that ACTL1101 is their favorite. But if they type anything else, everything should be uppercase, right? So favorite lowercase ACTL2131 should become uppercase, right? My favorite university subject is ACTL 2131. Said no one ever. Nah, that's a joke. That's a joke. I actually quite like this course myself. But you'll worry about it next year, I'm sure. So, well, I show you the solution. Again, the only trick is it's exactly as the previous example. The only trick is to make everything uppercase. You need to use this function to upper, and then the rest. Here, well, we use paste. Okay, we use paste instead of cat. Before we use cat. I'm not sure. I think cat doesn't have a separator. I think that's a different. Let me just double check the help here. No, it has a separator. So I actually don't know the difference between those two functions. I'm sure we can Google it, but maybe later. Okay, for now, the separator is simply when you put strings together, what should separate them, if anything, right? So we see this actually puts nothing in between, right? So meaning my favorite university subject is, now there's a space here. So then after that, directly ACTL comes, and then you see there's no space. There's no space here. If we type the same thing here, but we put separator to be one single space, then of course we're gonna have slightly different display. Here, there's gonna be two spaces because I already had one here, and then there's gonna be a space here. Those are details, but maybe worth mentioning. What is this sep thing? And again, let me just try because I'm curious. I think cat will do exactly the same thing then. Looks interesting. Cat for some reason doesn't have the quotation marks here. Okay. I'm not too sure why though. because in R, a character should really have the quotation marks. But anyway, I suppose I learned things myself. But then it's still not a numeric, right? So this is gonna, okay, interesting. That's a behavior I didn't know existed, but I can't really explain it to you then. Still, moving on. I think you already know a function can have many arguments. This is an example. We create a function that is the cumulative distribution function of the Poisson. Now, there's actually already a existing function that does that in R, but that's fine. We're going to create our own function that finds the CDF of the Poisson at a given value of x. You know, the Poisson has only one parameter that here we're going to call lambda. And we do this in a for loop. As I've explained in a previous video, usually you prefer to avoid a for loop if you can. We could definitely do this without a for loop, but I suppose maybe we take this as an extra practice of the for loop as well. So again, this is a name I'm giving to the function. I need a keyword function. Here I'm naming my two arguments, the x at which we evaluate the CDF, and of course the lambda, that is the parameter of the Poisson. Now I will want to add all the probabilities up to x, because remember, conceptually the CDF is the probability to be smaller or equal to x. So we need to add all the probabilities up to that value. So we initialize the value to display as 0, and then using the for loop, for every integer is going from 0 to x, we will add to CDF. We create a new CDF by adding to the old CDF, where our CDF is just this numerical object, the probability mass function of the Poisson evaluated at the specific value. Right here, careful, it's k. K will take the value 0, 1, 2, 3, blah, blah, up to x. So yes, at any given iteration, the probability that the Poisson takes the value k is this. Okay, this is just a theoretical formula. E to the minus lambda times lambda to the k divided by k factorial. Factorial is a function in R that already exists, that does what it says it does. And then at the end, that's it. Now the loop is executed for every k, and at the end we just need to return CDF. Okay, and this is the result. And here there's just a comment that we have every right to use a function within a function. For example, factorial is a function already defined. We use it inside our own custom function, and that is fine. Now see if you can do this without a loop, though. Maybe that's an exercise for you. Okay, but that's another exercise for you. Can you create a function which takes two arguments and calculates simply the binomial coefficient, right? So p choose n, which is equal to this mathematically. Okay, and test your function on evaluating the result of this. Okay, shouldn't be too difficult. I'll let you take a moment to type it. Okay, the result is there. Nothing special here. This is the name of the function, and then I need those two arguments, and voila. Okay, I believe this is something we covered already, but each argument can be associated with a default value, doesn't have to be. To specify a default value, when you create a function, you just set it equal to whatever the default value is, that you want. When the function is called with no effective argument for that specific argument, of course, the default value is used. Okay, so here, if I've created binomial to be the same function, but now I put explicitly that n equals 5, again, this means the default value is 5. Of course, it will be overridden if n is specified to be anything else than 5. But this means that binomial bracket with no argument specified will simply return, 3 choose 5, or I should say 5 choose 3, which is 10. And if you specify only one of them, so now you specify n is 6, but you don't specify p, well, p is, again, will be by default 3. And 6 choose 3 is 20. Okay, now there's a way to explicitly tell R to return something inside the function, and this is the command return. Now I say explicitly because you actually don't need return to return something specific, and there's a bit of a catch here, which is that if you use return, you should know that it will return whatever is inside return, but then the code will stop executing. So really, return, you should use it at the very end, unless, actually, I don't really know why you wouldn't use return at the very end. But the point is just this, be mindful. Return somewhere in the middle of the code will mean that the function will return that, and everything after will not be executed by the, well, by the function. So let's review this example, which is really for pedagogical values, right? I don't think, like, this part of the code doesn't really make sense, but let's just review what we mean. It's the same function, binomial, and now you see it worked perfectly fine before. So frankly, we don't need return, but the behavior of return is this: return factorial blah, blah, blah. This is exactly the same command to create the binomial coefficient. The behavior will be that the function returns this, and then everything else is not executed. Now, to prove that this works, if you look at this code for a second, this is what is called an infinite loop. So it's a loop that would never stop. And then R will either crash or you will need to stop it manually because it's never going to stop. Well, yes, because look at it. I create a random uniform. While my random uniform is smaller than 1, updated to be a new random uniform. But you see, the random uniform is a continuous random variable between 0 and 1. But because it's continuous, it will never be exactly equal to 1. It will, so hence, well, even if it was, actually, it's a smaller equal here. So even if it was exactly equal to 1, this will always, always, always be true. So this loop will never stop. Okay, so this is an infinite loop. It can happen sometimes by mistake that you have a loop that you messed up the condition, and the condition will always be true, and then the loop will continue to loop until the end of the life of the universe, and then that's not good for you. So let's just double check and copy paste this in RStudio to show you that I'm not making stuff up. If I type binomial whatever, I don't even need arguments here, but let's have 10 and 5. I get my binomial coefficient, but you see, this is because of return. If I don't have return, I hope this is not going to crash my R, in which case I'll be annoyed because I'll need to redo the video. But this will display this. Sorry, we'll execute this, but then we'll go here, and it's not going to stop. And you see, if I do that, nothing happens, and the code, I believe the code is still running here. Let's try. Oh, the code stopped. So it's not an infinite loop. I'm a bit surprised by this. Sorry about that. I figured out the problem. I'll go back to share my screen. Yeah, so I need to share. Yeah, we should be good now, I believe. So it is an infinite loop. It's just that I haven't called my function, right? So when I type this, I'm just creating my function. So far, there's no problem. I declared my function. But now, obviously, I need to use it. And now if I use it, now I'm going to have the big problem that, you see, this tells me that R is running. But I am in infinite loop because while this number is smaller than 1, update the number, but I'm updating it to something that will always be smaller or equal to 1. So this is going to run forever. I don't want that, so I'm going to click stop. And hopefully R has not crashed, and I can keep going. And yeah, if there is no return in the body of the function, well, then the function will return the result of the last evaluated expression. As long as it's the result of something. If the last evaluated expression is assigning a value to an object, the objects will not display by itself. I don't know if I'm being clear, so let me just come back to this function. So let's say that here, I'm going to just delete all this infinite loop stuff. Let's say that, again, I want to display the binomial, but for some reason, I'm creating an object called binom_coef, right? So that's function, it's okay, it's creating an object called that. But now, if I call it, nothing's going to happen because I've just created an object, but you see, I haven't returned it. So here I would have to specifically type here. Okay, and now this will this will work. It's gonna output again the last line of code, but now the last line of code is displaying something, which I believe has the exact effect of typing this as well, return. Whoops, I forgot the bracket, but that was just on purpose, right? To make sure you're following. Like this. Okay, moving on. Okay, an important comment. Variables defined inside the body of a function have a local scope during the function execution. But this means that variables inside the body of a function, well, any variable inside the body of a function is different than a variable with the same name that potentially exists in your workspace. So maybe I'll go to the RStudio to give you an example. Let me just finish those bullet points. Generally speaking, local scope means that a variable only exists inside the body of the function. After the execution of the function, the variable is thus automatically deleted from the memory. So it's not accessible anymore. Now, maybe you think this behavior is strange, but usually it's a good thing because it keeps the clutter of all the objects defined within functions that usually only have a local purpose away from our overall environment. Now I don't know if there's an example here. So yeah, there's none. So let me just illustrate this briefly. Again, let's go back to this function I just created. Bino_coef is defined only in the function. So you see, even if I declare this function, and even if I use it once, well, I've already done it, but let's do it again. Okay. Bino_coef doesn't exist. It doesn't exist in my, you see, if I go to my RStudio, my environment, those are the functions I created. Bino_coef doesn't exist. Let me show you as well. Bino.coef doesn't exist. Doesn't exist. Now, the other point that was made is that I could for some reason define a name with the same name, Bino_coef. I could say, okay, this is whatever number. Let's just say a fancy number like pi times expected value, not expected, but x2. So now I'm creating Bino_coef. Now Bino_coef exists. It exists because I've declared it in my main session. I haven't declared it inside a function. And the point is that this is fine. Like, it's okay to have an object inside a function that is the name of a different object. To make this crystal clear, let's say I define it even before my function. If I execute the whole thing, it's going to work. There's no problem to having this object have the same name as this one because it's inside the function. Hopefully that's clear. And we can go to the next slide, which is an exercise for you. Create a function in R that calculates the present value of an annuity. So paying an amount of 1 per year. Now the inputs are, so the arguments of your function, there should be something for the number of years. By default, it's 1. Whether the payments are paid in arrears or not. And by default, this should be set to true. So this argument is a Boolean one, true or false. and the annual interest rate to use, which is by default 6%. Now, if you haven't seen the financial maths part of the course yet, that's okay. The present value of an annuity is well, how much money do I need now to make payments of whatever amounts in the future at whatever interval? So in this case, payments of one every year for a set number of years, for n years. But now the mathematical results is here. This present value of the annuity that pays one at the end of each year for n years is this expression. Obviously, this can be proven. We'll do it in the theoretical part of the course. But for you here, for a programming task, I just want you to create a function that returns this, but that returns this if the argument here specified by the user is true. Otherwise, if payments occur at the beginning of the year, then the present value is different, and in that case, the present value is this expression. And so your function should deal with both cases. So again, there should be an argument for the number of years, an argument that is only has two values, true, false, for whether or not the payments are in arrears. And if so, that's what is displayed. If not, this is what is, well, I said displayed, calculated and then displayed by the function. Let's see if you can figure this one out. And for myself, I'll go to the solution. I suppose there's more than one way, but here, the name of our function will be annuity cal for calculation. Now, n is by default 1, arrears is by default true, interest rate is by default 0.06 for 6%. Now here, we declare something that is the discount factor. So the discount factor is 1 over 1 plus the interest, because you see, this is in fact 1 plus I to the minus 1 is the discount factor. I suppose we didn't really have to define something that is the discount, but here maybe it makes this this formula slightly easier, like 1 minus discount to the n divided by n is exactly this. Sorry, I've gone back too much. And then I think there's a mistake here, right? Because it's 1, it should be 1 minus. Yeah, this should be minus. Because yeah, the annuity, this is actually correct, right? This is correct, and this is incorrect. So I'll fix this in the slides later. So sorry about that, but this is the correct formula. But the point here in terms of code is simply that if arrears is true, then what we want to return is exactly this. And again, apologies for the mistake, but you see, provided that this was a plus, or I should say, provided this was a minus, it would exactly match the formula here. So if arrears is true, you want to return this thing called temp. But else, so that's an example of the if else. Else, here there's only two possibilities, so we don't need if else, we just need one else. So if this is not true, then return the other expression. The other expression would be this. Again, there should be a minus here. And then that's it. That's it. You see, I suppose, well, return here makes sense, but I think that would work even without the return, right? Let me just try. If that, yeah, I think so. I think it should work. I'm saying if this, then just display this. Yeah, seems to be working. The same way. And then that's it. Well, those are just other examples. If A for arrears is false and everything else is set to default, well, you're just going to get a 1 because it's like a payment of 1 that happens right now. It has a present value of 1. And here another case, you can double check that you agree with this answer. Okay, other exercise. This one uses the plot function that we haven't covered. So frankly, I don't think you're expected to know how to use plot for now, but I'll just review the exercise briefly. Create a function in R that plots the density or distribution function of a normal. So here again, we want you to practice. There's two possible outcomes that depends on what the user has entered. And the argument should be the mean of the normal we want to display, default of 0, the variance default of 1, and of course whether a density function is plotted, which is by default true, and if false, then the cumulative distribution is plotted. The output is either the density or a distribution function. By distribution function we mean CDF, but specifically on this range, right? Mean plus minus 4 times the standard deviation. And yes, so you will need D norm, P norm, and plot. Again, a bit hard for you to do this right now, so I'll just go to the solution. So those are all my default arguments. The mean, the variance, the density equals to true if I want the density. Now here I'm creating a sequence that goes from, this is a sequence of points from the lower bound of the interval I want up to the upper bound by simply this. Mean minus square root of the variance will be the standard deviation, 2, and then by. So the argument by a function sec is just giving me what's the intervals of those between elements of the vector. And here, just kind of arbitrarily, I choose this, which should be relatively small, such that between 2 points at which the function is evaluated, there's a relatively short gap. But you could have put whatever number here, like small number, 0.01 or. And then if density, now here, this works because density is already a true or false, right? So if density is the same thing as saying if density equals true, right? So just a bit of a shortcut. Because density is already a true false, it works. If density is true, then do this. And again, this again is the use of plot, but plot here, very simple use. There's many ways you can use the function plot, but for now, it's just a scatter plot. So literally here, this is a vector of x values. This is a vector of y values, and the result will be the scatter plot of all those pairs of points. And here, d norm is this density of the normal distribution evaluated at all those x's, specifically for the mean and specifically for the standard deviation here. So again, d norm is the density that one shot finds a vector of all the densities the densities evaluated at those specific x values. Else, well, exactly the same thing, but now we want to plot the CDF, and this is given in R with P norm. So D norm for density and P norm for CDF. Okay, and I believe that's it. Then if I call P norm without arguments, all of those defaults are used. If I use P norm, but now I want for some reason I want a mean of 1, that's fine. The mode here will be closer to 1, and variance of 4, meaning standard deviation of 2. And then lastly, this gives me the CDF, right? So of course, it's going to be an increasing function that is closer and closer to 1 as I get more right on the support of the random variable. Okay, lastly, just a few comments about the help menu. So this is the menu you can use to get a description of a function you want to use. So it's important to learn how to use other people's functions. By other people's here, we mean the developers of R, I suppose. For any given function, I don't know why 4 has a capital letter here. You will get the required inputs of the function, the outputs, and then of course some extra details on how the function works and some examples. So here there's a specific example with the function sec. Now again, let me just remind you that here there's a search bar, right? So you could just type sec, and I believe it should bring you. Okay, you have a few options. So if I type sec, it's going to give me it's going to open the page that's specifically about the sequence, well, the sec function, and again, question mark sec also works. Let me just go to a different page. I don't know, the function histogram here. if I type question mark sec here, I'll go back to my function sec. And so here, there's a few things. There's a description. This is just a brief overview of what the function is intended to do. So in a sense, an overview of the function, generate regular sequences. Then usage. So this shows you how to use the function, and importantly, what arguments it takes and what the default values are, if any. For sequence, or I say sequence, the function is called sec. The key ones are from, to, by, and length out. I believe there's another one, another argument here, along with that's well, it's definitely an argument you can use. It's probably not as common to use along with. Along with, you can use it to essentially create a sequence that will have the length of a specific the same length as a specific R object that you specify with along with. So I know it's not very clear what I'm saying. So let's try sequence. So if I just type sequence and then I type only one argument, so only along with, and then inside I put whatever object I want. Okay, so for example, if I type a vector here, a vector of whatever, I'm just gonna type random values. Okay, that sounds weird, but it's gonna, I think it's gonna work. No, it's not gonna work. Because my syntax is incorrect. Along with equals this, of course. Now I have one too many brackets. So here with debugging in real time. Okay, so then it worked. But what's the logic of this? This vector that is just random values, well, random in the sense that I just invented them, has 5 values. So sec along with those 5 values is just going to create a vector of length 5. Okay, but if I have type other arguments, so let's say sec from 6, but now it's going to work, but now I'm going to start from 6 and having a vector of length 5 again here only because this vector has length 5. Okay, but I think that's enough about this along with. But in general here in the help menu, they will tell you what those arguments are. Sometimes, to be honest with you, the description is not entirely clear. So here, for example, along with, take the length from the length of its argument. That to me it's a bit confusing, right? But most of the time, I think you'll get reasonable explanations about what those arguments are. Okay, by increments of the sequence, this length out, desired length of the sequence. So let's just try sequence. If I want a sequence from 1 to whatever, let's say a big number, like, I don't know, 100,000. Now length out. Now, if I just do this, it's going to be a super long vector because by default, it's going to be increments of 1. But if I say by big jumps, like say 10,000, well, that's going to be fine. It's going to do jumps of 10,000. And you see, because I say the jumps need to be 10,000 and I start at 1, it's not going to reach exactly the upper bound. So careful with this behavior. If I type instead length out, this is how many elements I want in my vector. So if I want only 5, no. Why does that not work? I'm a bit puzzled. Desired length of the sequence. Okay, obviously, I cannot spell English, so it's length, okay, like this, okay? I blame my elementary school English teachers for letting me pass, but you see, now I get what I want. I wanted 3 elements in this vector that start at 1, finish at 100K, and in between are at regular intervals. Okay, and here maybe I'm speaking too much. This is just the point that you get all the arguments that you can read and understand how they work. Again, using the help menu. Okay, this is what I said. Now, just a comment for this specific function, by and length out, they seem overlapping because they are. So you need to specify one or these two. So either you say, I want the sequence to be increasing by a certain element, or another way to specify the sequence is to say, I want a set number of elements in it, which is length out. You can't use both because they have kind of conflicting objectives. But the point is just sometimes it happens, right? Sometimes you need one argument out of two only. Okay, this, you may also know that the default argument of by is calculated from length out. Yeah, you can see this. You can see this again in the help. If you check that by is in fact a function of length out, meaning that when length out is specified, by needs to automatically be set to that. Otherwise, it doesn't make sense, right? Like I can say that I want, I want a sequence that goes from 10 to 20. I can say at the same time that I want by increments of 2, and also I want and also I want this to be a sequence of size 100. That doesn't make any sense, right? If it's by increment of 2, it cannot be of length 100, right? And of course, this then gives me a mistake or error, I should say. Okay, then in the help menu, you'll have some information about values. This is what the function will output. For sequence, it can tell you something about the fact that it outputs a vector. And of course, here there's only one result, but some function can display a list of result, in which case you might have quite a lot of information in the value section. And then details, this describes any extra details of the function's behavior. Often this will be stuff that is kind of more advanced, or maybe you don't need it. So frankly, look at this only if you need to understand it, like only if you don't understand what the other things here, what the function does. And frankly, how good the documentation is for different function varies. Sometimes you read it and you're like, okay, I don't really know what I read, in which case, well, maybe you go to Google or your friend ChatGPT, I don't know. And then lastly, there's some examples that, again, can be quite useful to understand in a quick snapshot. So here you see you have details here, but then at the end you have examples. And here maybe it is actually quite helpful to know quickly, okay, what are a few use cases of this function? Okay, I believe that's probably the end of those slides. I'll leave you with the homework and hope to see you in the next video. Bye-bye for now.